My name is Jim Stokely. I'm with the Wilma Diamond Legacy. I want to welcome you to the first of 5 Saturday afternoon talks in our series entitled Water Troubles and Water Solutions, Western North Carolina Water in Context. I'd like to say a few words about the Legacy. We are a tax-exempt public charity located in Weaverville. We were founded in 2012 to sustain and promote Wilma Dykeman Stokely's core values. The three innermost values we have identified as environmental integrity, social justice, and the power of the word. The Legacy sponsors lectures, programs, and other events such as this in the Asheville area. We are not a bricks and mortar organization. Mother was not a bricks and mortar kind of person. We are a virtual entity. We partner with various organizations in the area like RiverLink, the Osher Lifelong Learning Center at UNCA, and Buncombe County Public Libraries, as well as others. We have no paid employees. All of our member contributions go to honoraria, travel expenses for speakers, as well as printed materials such as the brochures and bookmarks you have in your hands. So please consider becoming a friend of Wilma Dykeman so that we can continue producing programs like this in the future. And before you leave, please do two things. One, complete the speaker evaluation form. Don't complete it now because you haven't heard the speaker. But before you leave, complete it. It'll take you about 30 seconds. And also, if you have not already, sign up for a free monthly Word from Wilma. I think you'll be interested in her 1 or 2 paragraphs per month on a certain concept or word. Now I'd like to say a few words about Alan Deceased, who will be our introducer for the main speaker this afternoon. And as well, Alan will make a few remarks about what he's heard following the speech, and then we'll go into questions and answers. Alan lives near Alexander, a village on the French Broad River adjacent to Buncombe County, Buncombe County's border with Madison County. He earned his Bachelor of Science degree at the State University of New York at Rockport, and then his Master of Science degree at the University of Georgia. He's currently president of Eyes on Earth, a company that provides satellite-derived temperature and soil wetness products to the United States Department of Agriculture. You won't find these products on these shelves at Walmart. His customers include the USDA, Renaissance Reinsurance, Kazakhstan, and the State Department. These products are used to monitor crop development, predict yields, and manage water resources around the world. Prior to Eyes on Earth, Alan was employed at Weather Predict Consulting. He was co-founder and CEO of Commodity Hedgers, not a hedge fund, but it's another climate-oriented fund. And he served as research meteorologist at the Climatic Prediction Center and the National Climatic Data Center of the National Oceanic and Atmospheric Administration. Ladies and gentlemen, Mr. Alan Deceased.
Hello, everyone. I'm glad you're here on a beautiful Saturday, and I know it's a little bit hard to come inside when we finally had a nice Saturday to go out and celebrate spring here, and then it's going to go away again in 2 days. So, but it will come back. I'm here to introduce Carla. She came all the way down here from D.C. to give this presentation. She's actually a little bit enthralled by our community just from the glimpses that she's had of it since she arrived late last night and walked around this morning. She is a program manager at the United Nations Environmental Program, and her primary emphasis, although she is basically office manager in ecosystems, her focus is water, and so she works with terrestrial water issues, marine and coastal issues, as well as wastewater and how it's impacting the quality of our water throughout the whole hydrological ecosystem. Prior to joining the UN environmental program. She was the fellow at ORICE, affiliated with the EPA. And before that, she was in Puerto Rico, so she's done her fair amount of traveling. In fact, I found out that she was born in Mexico, grew up largely in Puerto Rico, but obviously working here in the States now. She was working on waterway restoration issues in Puerto Rico, so she's got a good perspective of issues outside of the United States and some of the issues from a developing country's perspective as well. In fact, that's what she's here to talk to us about. She's here to talk to us about the global perspective of water, the issues, since it is, frequently, we look at our own local issues right now. Asheville certainly has its own issues with water, but it is a global issue, and as the population continues to grow and more resources are demanding and more ecosystems are being undermined, then we have to be smart about how we use water. It is a renewable resource, but if you don't manage it properly, it's not. And there will be a lot of issues related to water, scarcity of water, contamination of water, sharing of water between boundaries. So the globe is going to see more and more issues and potentially conflicts related to water. So that's why we're here right now, to figure out how we can look at it from a progressive point of view and use our water wisely so that it doesn't become an issue of conflict in the future. So with that, I'd like everyone to welcome her, and we'll have our primary speaker.
Well, thank you so much, Jim and Alan, for the introduction, and it's really a pleasure to be here today. From what I've heard of Wilma Dykeman, she was really ahead of her time in terms of a lot of issues, including environmental issues and water in particular. So it's really an honor to be here, and I'm already loving Asheville from the little bit that I've been able to see. So actually, since I am really bad with time, maybe you can let me know if I'm going a little bit too long. That would be great. So, as Alan mentioned, I work for the United Nations Environment Program. I am a program officer, and UNEP, hopefully many of you have heard about it. It's the environmental branch of the United Nations. It's a relatively small agency, but we work on a lot of the science and policy for all the other UN organizations dealing, and we particularly deal with the environmental side of things. And we have a very small regional office here in the US. We have bigger offices in Latin America and the Caribbean, Africa, West Asia, Asia Pacific, and Europe. But we're the only office that only works with two developed countries, the US and Canada. I learned when I started that Mexico was not considered North America in this context, because it's pulled together with the Office of Latin America and the Caribbean. Makes more sense in many ways. So I am here to talk to you today about water troubles, and I think Jim and the colleagues at Wilma Dykeman Legacy have prepared a really interesting lecture series. So I hope that you're going to be able to get this, intro today and attend the other ones, because they really sound like they will be really, really interesting. So I want to start, and hopefully now the technology will work well, with a video that gives a great overview, and it's from the University of North Carolina. It's the School of Journalism and Mass Communication. They've partnered with the Water Institute, and they've done a series of incredibly good videos. And this is part of a series called 100 Gallons, Powering a Nation. So let's just, without further ado, start with that.
Water is familiar, seemingly ordinary, even commonplace. But our bodies are more water than anything else. Water is essential to life, even in ways we don't realize. It takes 13 gallons of water to produce 1 gallon of gasoline. It takes 1,000 gallons of water to produce just 1 gallon of milk. In U.S. homes, flushing the toilet uses more water than any other activity. That's 2 gallons per flush. More than 1 billion people live on less than 1.5 gallons a day. Think about it. That's less water per person than in a single flush. If all the world's water fit into a 1 gallon bucket, the drinkable water would fill a tablespoon. And not all the water in that tablespoon is available. 2/3 of it is trapped in glaciers. Some of it is in the atmosphere, and every day, 2 million tons of waste contaminate the fresh water we can reach. That much waste is equal to the weight of the entire human population. The combined effect of pollution and scarcity leaves almost 900 million people without access to clean water. That's about 3 times the population of the United States. While you've been watching this graphic, 4 children have died because they didn't have clean water. Almost 2,000 gallons of waste have been dumped into our water, and the United States has consumed over 4 million gallons of water. When it comes to water, every second and every drop makes a difference.
And I encourage you to look at the rest of the series. It's really good. I will, if we have the time, I will present another one as part of this presentation. So, going back to it. You know, what the video mentioned, tablespoon in the bucket. So this is our context. We have a lot of water in this world, but most of it, of course, is salt water. 97.5% is salt water. Fresh water is only 2.5%, and of that, most of it really is trapped on glaciers and on permanent snow, so approximately 68% of that. 30% is groundwater, ground ice and permafrost is a small amount. And then of the very small, 1.22%, a lot of that's the part that we are able to utilize for human uses every day, and 26%, most of that is really on lakes, then also soils, atmosphere, wetlands, rivers. So I think the video presented that very well. So this is our context, and I don't know if you know, but today is World Water Day. How many of you had heard of the UN World Water Day? Okay, a couple of people. That is good to know. And today's World Water Day, this year, it's the focus is on water and energy, and I'm going to come back to that.
Could you speak as loud?
Yes, okay, sorry. I will speak loudly. Maybe I can try to put this a little closer. So now that we've seen, the freshwater context, let's take a look at some of the challenges that we're facing. Around 700 million people in 43 countries suffer today from water scarcity. And by 2025, 1.8 billion people will be living in countries or regions with absolute water scarcity. And 2/3 of the world's population could be living under water stress conditions. And in addition, water scarcity in some arid and semi-arid places around the world will displace between 24 million and 700 million people from their homes. And there isn't one measure of water scarcity, and if you look at other maps of the U.S., it will show the U.S. and North America in general has quite a lot of availability of water per capita. So we could think, oh, we're fine, but of course that's not in every part of the U.S., and we're certainly utilizing much more than we should per capita, and we have one of the largest water footprints of the world. High overuse tends to occur in regions that are heavily dependent on irrigated agriculture, which is, as many of you know, one of the major uses of water around the world, such as the Indo-Gangetic Plain in South Asia, the North China Plain, and the high plains of North America. And also in areas that are undergoing rapid urbanization and industrial development. And one example of very quick urbanization with a lot of water footprint is Las Vegas, as many of you know, which is the fastest growing city in the U.S. in a very dry region. So it's certainly, even though the per capita water for the U.S. is pretty big, it's not the same in every part of the world. And we're certainly overpumping much of the water in our aquifers. Recent evidence has shown that groundwater supplies are diminishing, with an estimated 20% of the world's aquifers being overexploited, and many of those really massively so. And as you can see in the U.S., that's certainly true. Another issue also related to our water use is river fragmentation. And here in the U.S., you're going to you see there, that we have put a lot of dams in our rivers historically. And of course, dams have important benefits for human development, and they provide reliable water supplies. They're important for energy production, but they come at a certain cost as well, and I'll come to that in the next slide. Dam density is highest in industrialized countries, but the construction of dams has decreased with years because there's a lot more public awareness about the detrimental effects to ecosystems that they have. But in the developed world, dam building is being actively pursued in many developing countries to secure water and electricity supplies. And this trend is likely to continue. So we need to look at ways to better build dams to reduce some of the problems that come with it. And one of the problems, of course, is the impact on biodiversity. As we know, dams can really have huge impacts on ecosystems, including channel fragmentation, flow modification, and they affect aquatic organisms, especially migratory species. I think many of you know about the real difficulties that salmon has had, especially in western United States. So we've talked a bit about the freshwater context. We talked about the challenge of scarcity. We're overusing the water. But then also once we draw it, we're overdrawing water, and once we have it, we're using it very inefficiently. We are, as the movie presented, we're flushing a lot of our clean water down the toilets. We don't utilize necessarily the technologies that exist. And agricultural and industrial, actually I'm still in irrigation. So irrigation, as you know, is the biggest water user in the world. It's about 70% of water use. And if we were able to just implement the irrigation technologies that exist now, we could reduce the water footprint of irrigated agriculture by 1/3. And imagine what we could achieve with many additional technologies that are being developed. So agriculture and industrial are the two largest users of water, and in the US they're about the same amount each. And 75% of all industrial water withdrawals are used for energy production. And of course we can also not forget, our, do you have a pointer here? Maybe not. If not, that's okay. We should not forget our municipal water use, and as I mentioned, that we also see a lot of inefficiencies in our municipal water use, the same way as we see it in also energy production. And I do want to give you a good example of improving municipal water use efficiency, and it's the city of Albuquerque, New Mexico. Municipal water use dropped consistently from 251 gallons per person per day in 1995 to 157 in 2010. So that a typical home with the latest appliances uses 22% less water than an older home. So basically in the 80s, people in Albuquerque thought, we live on a massive reservoir. We have enough groundwater for a long time. People were, putting lawns in all their houses, and then when they realized what the real water constraints were, there was a real effort from the municipalities to really address that, and using technologies like low flush toilets, many other types of water efficient faucets, etc., and also dealing with landscaping. I mean, they've been implementing a lot of seriescaping, so not putting lawns and things that really don't go with that part of the world, but really planting the type of vegetation that is better suitable for an arid part of the world. So we overpump the water, or we withdraw water, we use it very inefficiently, and along the way we pollute it. So, now a few of the issues of contamination, a big one, and it's a really big one here in the US as well, is nutrient runoff. And as we know, nitrogen and phosphorus provide development benefits. They're really important for food production, and rightly so, but they cause a lot of environmental problems. As this figure shows, half of the world's food security is dependent on nitrogen and phosphorus fertilizers, but excess nutrients, and this is the problem, that we're not applying it at the right time, in the right place, and in the right amounts, and these excess nutrients end up running off, going to our streams, eventually to the oceans, and causing a lot of problems. And I would like to share with you a video that we produced with cartoonist Jim Toomey. I don't know if any of you are aware. He's a syndicated cartoonist. His column, Sherman's Lagoon, his cartoon, Sherman's Lagoon, appears in a lot of newspapers around the US. And he's an oceans advocate, and he's been working on this series of videos with us. So it's just a 2-minute video, which I think shows very short and sweet some of the issues of nutrient runoff.
You might not realize it, but what we do on land has an enormous effect on the ocean. For instance, as the world's population grows, we're demanding much more from our farmland. We're applying more and more fertilizer, which contains nutrients like nitrogen and phosphorus to increase food production. However, too much fertilizer on farms and on lawns and gardens is a problem. Why? Because when we use too much of it, or apply it in the wrong place or at the wrong time, plants can't absorb it all. These excess nutrients get washed into streams and rivers, and eventually into the ocean. This process is referred to as nutrient runoff. Fertilizer in the water makes algae grow. A bountiful crop on land might be a good thing, but a bountiful crop of algae in the water can be a disaster. Here's why. Excess algae block the sunlight that aquatic life needs to survive. Some algae also release toxins that impact human health. Worst of all, when algae die and decompose, they consume all the oxygen in the surrounding water. This results in widespread fish kills and habitat destruction, creating so-called dead zones. Enormous dead zones in the Gulf of Mexico and the Chesapeake Bay have already had an impact on the health and economies of people living there, costing the United States an estimated $2.2 billion annually. And the problem keeps growing. Dead zones have increased around the world from 10 in 1960 to 405 in 2008. Fortunately, there are things we can do to help. If you have a yard or garden, use fertilizers in moderation. Consider planting more native species, which require less fertilizer. Consider buying organic food. If you're a farmer, look for alternatives to phosphorus and nitrogen-based fertilizers, and use fertilizers more efficiently. Consider using cover crops as nutrient filters and buffers to reduce runoff. If you're a decision maker, you can put in place measures that improve the management of nutrients. Less waste of fertilizer not only benefits the ocean, it saves money. So do your part to reduce nutrient runoff and protect our oceans.
So I can't begin to tell you how much fun it has been to work with Jim on the production of some of these videos. And let's see, escape. Oh no, why didn't we go back? Let's get back to here. So actually, one thing that I did want to point out is that whereas excess nutrient is a big issue for the United States, as you saw in the movie, and for other parts of the world, there are parts of the world where the problem is the opposite. They really do not have enough nutrients for food production, and that's why there's a lot of issues of food security in certain parts of Africa and Asia. So just to keep that in mind, it's not always nutrient excess, although that is a huge problem. Another part of the problem is wastewater, and globally 2 million tons of sewage and industrial and agricultural waste are discharged directly into the world's waterways, and this has huge public health concerns. 1.8 million children under the age of 5 die every year from water-related diseases, or 1 in every 20 seconds, like the movie presented. Over half of the world's hospital beds are occupied with people suffering from illnesses with contaminated water, and more people die as a result of polluted water than are killed by all forms of violence around the world, including wars. So it is definitely a big issue. And I forgot to mention in the previous one, but the United Nations Environment Program, GPA, bear with me, it's a long name, the Global Program of Action for the Protection of the Marine Environment from Land-Based Activities. So it's a terrible name, but it's land-based sources of marine pollution. It's addressing the issue of nutrients through a global partnership on nutrient management, which is currently chaired by the United States Department of Agriculture. It's a global partnership. And also very recently, we started a global wastewater initiative that is addressing some of the issues that I mentioned here. So as you can see, up to 90% of untreated wastewater flows are generated in densely populated areas. So around the world in general, 80% of the wastewater flows into streams and rivers and then to the oceans. But in the developing world, 90% of that is untreated with huge public health but also ecosystem results. And the third area that this Global Program of Action on Land-Based Sources of Marine Pollution is addressing is the problem of trash, or marine litter, marine debris is what it's called more here in the US. And as many of you have probably seen, there are huge plastic gyres in 5 oceans, in the Indian Ocean, North and South Pacific, and the North and South Atlantic. And it is a problem that is so visible. It's really caught people's attention, and it's one of the areas that we are addressing. It poses huge threats to wildlife. You can see some of the pictures. Actually, I won't say too much more because we do have a good video with Jim Toomey that I'll present. It's also one of these 2 short 2-minute videos that will explain it much more eloquently than I can do so. Here.
Cigarette filters are also a common source of marine litter. You may not think they amount to much, but cigarette filters are one of the most common items found in beach cleanups. Marine litter also kills animals. Seabirds are programmed to eat small things that are bright and colorful and feed them to their chicks. Sea turtles can't tell the difference between their favorite snack, jellyfish, and plastic bags. And fishing gear, such as nets and lines, continues to catch and kill long after it's been lost or thrown away. Invasive or alien species have been known to catch a free ride on floating litter, and this can wreak havoc on native wildlife. There are ways we can help. Dispose of waste properly, recycle more, and switch to reusable containers where possible. And participate in beach cleanups. Industry can do a better job designing products that use less material and don't just get used once. And the next time you're given the choice between paper or plastic, say neither. We can all help solve the trash problem by making less of it.
Okay, so those were the 3 main areas that we're working on in terms of land-oceans connections. And in terms of the marine litter, UNEP is working with the Food and Agriculture Organization and with the International Maritime Organization. They are addressing the sea-based sources of pollution, because a lot of this is also discarded fishing gear. But as you saw in the video, 80%, approximately 80% of the ocean trash comes from the land. So clearly we need to address this in an upstream way, which is why the International Coastal Cleanup, I don't know if you've heard of it or participated in it, is going more and more upstream. You know, you're not only going to beaches, but you're going to the rivers that eventually bring the trash into the oceans. So we've touched on various issues, water scarcity, overusing of water, inefficient use of water, and pollution along the way. And now I just wanted to take a quick look at some global governance approaches and as well as some strategic approaches that are happening in various regions and countries. And how many of you have heard of the Millennium Development Goals? Millennium Development Goals. Okay, great. Quite a few of you. And in 2000, the world governments really agreed on a set of 8 key goals for human development. And the idea was that they would be achieved by 2015, which is approaching very quickly. And some of them they range from education, improving maternal health, reducing child mortality, several things. Some have had more success than others. In terms of water, as you can probably not see so well on this graph, but in terms of water, the MDG, Millennium Development Goals, that has to do with improving access to secure water has been met. There's still a huge gap, especially in certain parts of the world, because part of this percentage of people being able to have access to water has occurred in cities, but many rural areas in many parts of the world, that has not been achieved, and it's still, it's not going to be achieved by 2015. So we need to continue to. That has been achieved, the overall goal, but in terms of reaching some of the furthest and poorest of the poor, it hasn't always been reached. And in terms of providing access to sanitation, to adequate sanitation, that is still well below the mark for 2015. So it's certainly an area where we need to work. But these Millennium Development Goals really galvanized a lot of efforts around the world in working on these specific issues for human development. And now that we're getting close to the end of those of when those goals were supposed to be achieved, and some of them have not, and some, even if they have, there are still gaps. So now the world is thinking of the post 2015 Sustainable Development Agenda, and one of the efforts that's come out of this is to develop Sustainable Development Goals where the environment is brought in much more of a forefront way than it was in the MDGs. The Millennium Development Goals were really aimed more at poverty reduction and some really important issues, education, etc. And the Sustainable Development Goals really builds on the MDGs or hope to build on the MDGs, but bring environment also closer to the discussion. And these are going to be agreed on at the end of 2015. So there's a lot of discussions right now. There's a lot of different themes at the table. Of course, water is one of the key issues that's being addressed. There's a specific focus area on water and sanitation, but water also plays a major role in several of the other potential goals. For example, sustainable agriculture, infrastructure, as we'll see in a minute, sustainable cities, which also require water, etc. So once again, we're on World Water Day, and there's a new report that will be launched today, although last time I looked, it was still embargoed, but I really do suggest that you visit the website. This World Water Development reports used to be produced every 3 years, and they were pretty comprehensive assessments of what's going on around the world, but they've now decided to do them every year with more of a focus area. So this is the first time that it's one of these yearly reports, and it's focused on water and energy. And so once again, I wanted to present another video from the students of Chapel Hill, of the School of Journalism, because I think it really shows very well maybe we won't be able to present this one. Well, it worked before. Well, in any event, I encourage you to take a look at it. Maybe if we get some technical support before I finish, I can show it. But as I said, it's part of this 100 gallons program, and it's very good, and it shows some of the connections between water and energy. Water really is dependent on energy, and energy is depending on water in many ways. And how can I get out of here? Okay. Let's see if this one works.
Everyone has a right to security of water, energy.
Oops.
Everyone has a right to security of water, energy.
So this video, the other one was specifically on water and energy. This video that you're going to see now is on the water, energy, and food nexus, which is something that's being discussed quite a bit around the world, and I'll touch on that, but this provides a very good example. You'll see that it's produced by a private sector entity. I think in many ways the private sector is catching on to this importance of looking at the three, at water, energy, and food security together, much more quickly than many governments.
And food has a right to security of water, energy, and food. But in a world of 7 billion people, 1.1 billion live without clean drinking water, 1.3 billion live without electricity, 1.02 billion are hungry. And it's not like the world is standing still. Population growth and urbanization mean that by 2030, we'll need 30% more water, 40% more energy, 50% more food. Our solutions often treat water, energy, and food security separately, but they need to be seen as interdependent. For example, it takes 1,300 litres of water to make 1 kilogram of wheat. By 2030, we may need 10% of our cropland for biofuels. In the US, moving, heating, and treating water makes up 13% of electricity consumption. Failing to treat water, energy, and food as a nexus leads to questionable decisions. The use of biofuels almost tripled in the EU between 2006 and 2012 in an attempt to increase energy security. But biofuels consume 20 times as much water as gasoline per mile covered. By competing for cropland, biofuels have increased cereal prices on world markets. Plus, biofuels release methane and nitrous oxide, arguably making their carbon footprint worse than fossil fuels. Nexus thinking also encourages you to think globally. Solving water security issues could create food security issues elsewhere. Some developing countries that have least fertile, well-watered land to wealthy countries still receive food aid. So are all parts of the nexus equal? No. Water security is key. Water is not substitutable or replaceable. We cannot create or grow more of it. Up till now, it is water that has been the least considered part of the nexus. Many countries are extracting groundwater faster than it can be replaced. China by 25%, India by 56%. That's why 700 million people live in water-stressed countries. And 3 billion will by 2025. It is also why many of our methods of producing food and energy impact on water quality. Whether it's the 17,000 litres of water per megawatt hour that evaporate from hydroelectric dams, or the 50% of nitrogen in fertilizers that isn't absorbed by plants, often running off into rivers. If we carry on as we are, our problems will only increase. Especially in an age of global warming and population growth. However, if we use nexus thinking, everything changes. Forward-thinking businesses are trying to speed up these positive feedback loops. At SAB Miller, we're generating renewable energy from reclaimed agricultural waste and wastewater. We're working with smallholder farmers to improve their yields. We're reducing the water we use in brewing and packaging our beer and cutting the energy required for heating and cooling. If we all put the nexus at the heart of what we do, our future could be brighter than ever.
So that was the last video that I wanted to present. It's actually one of the videos that's being highlighted throughout the World Water Day. It has more than the water and energy nexus, but really because we're trying to think of all three, and they are all very well related. And as I mentioned, it's really key that the private sector is engaging in this because, clearly they have a lot at stake here as well. And in some ways, they're thinking about some of these issues much more quicker and are moving faster than many governments. So what is this, this challenge that we have? By 2050, we're expecting to have 9 billion people, from the 7 billion that we have now. We expect 50% more need for water, 60% more demand for food, and 80% more demand of energy. And of course, this population increase, huge population increase, will need to be serviced with the water, energy, and food that they need. And put all this in the context of climate change, and this is a pretty difficult scenario. Zooming in a little bit to the energy and water part of this nexus, energy production is pretty water intense, and I'm taking some of these graphs from a report, an initiative from the World Bank, which is called Thirsty Energy, which is looking at, how power, electricity production utilizes so much water, and how we need to think of these things. For example, thermal power generation, which accounts for roughly 80% of global electricity production, and is responsible in the US for about half of the water withdrawals, and also in Europe, is pretty water intense, especially for cooling. Hydroelectricity they also require, of course, pretty abundant supplies of water, and also the reservoirs, there's a lot more evaporation going on than on flowing rivers. And this is part of the water that gets consumed and doesn't continue to flow downstream. So of course it impacts future populations, human and ecosystems downstream. Biofuels has been a huge issue, as we're trying to deal with issues of climate change as well, and trying to reduce the production, the use of oil and gas. We've gone to use more biofuels. This is still a relatively small part of the sector. But when we produce crops to produce energy, we're also consuming a lot of water, especially if it's done in irrigated areas. So it can really increase this demand for water that we already have, and it makes a competition between the land and the water that we use for food production and the land and water that we use for energy production. So, that is certainly a big challenge. And unconventional oil, like the tar sands, and also unconventional gas production, like fracking, are generally much more water intensive than even conventional oil and gas. Around the world, approximately 78% of world electricity generation comes from thermoelectric, including coal, oil, gas, and nuclear. About 20% comes from hydroelectric, and only 2% comes from geothermal, solar, and wind. And solar and wind are really the ones that utilize the least water. I mean, in the case of solar, there's a caveat. Some types of solar, concentrated solar, is relatively water intense, but photovoltaic utilizes very little water just to clean up the systems, etc. And also wind energy water use is very minimal. So it's one of the things that we need to think of as we have more people and need to, achieve provide energy to all of them, while at the same time providing water and food. So by 2035, global energy consumption will increase 50%, increasing water consumption by 85%. But as we mentioned before, still today, 2.8 billion people live in areas that have high water scarcity. 2.5 billion people do not have access to energy or have unreliable access to energy. And of course, put this in the context of climate change, and we have a big problem. And the UN and the World Bank have been partnering in an initiative by the Secretary General that's called Sustainable Energy for All, and are trying to address some of these issues. So zooming a little bit out again to the three, to the water, energy, and food nexus, as I mentioned before, we require water for energy production, in the extraction, in the cooling of plants, obviously in hydropower. We need energy to be able to access water, for water pumping and distribution, for water treatment, for seawater desalination, which is of course very energy intensive. And we need both of them for food production as well. We need the water for the food production, we need the energy to distribute it, and also for some of the practices on land, the tractors and all the other, also nitrogen, etc. And all of this happens on the land. So that's one of the areas that UNEP is really working on, bringing this land dimension, because this is not happening on the vacuum. And there really is a greater awareness of this complex interconnectedness between water, energy, and food. And this has sparked some discussions internationally, starting in 2011 in Bonn. This nexus concept came about in those discussions, which were spearheaded by the German government, the World Economic Forum, the International Policy and Research Institute, and this all happened in the run-up to the Rio Plus 20 conference, which was 20 years after the first Rio conference in 1992. We had the Rio Plus 20 conference in 2012, and so a lot of this nexus discussion was brought to these international discussions in Rio. And many organizations are working on different aspects of the nexus, and UNEP thought to itself, what is our best contribution to the nexus? I'm not going to go too much through this, but different organizations have different emphasis on the nexus. Water, energy, and food is the key part, but some others are including the climate change dimension, the land dimension, and in the case of the Transatlantic Academy, they're bringing in also the minerals part. For UNEP, and this is a graph that's probably going to change many times, but really what it's trying to say is that for UNEP, we're really trying to encompass this water, energy, and food nexus in the land where it's happening, so at the landscape level, and looking at the ecosystems that are necessary to achieve these three securities. And of course, not forgetting the climate change and all the problems that are happening, and all the uncertainties that we have because of climate change. So we're really looking at an ecosystem service emphasis within this water, energy, and food nexus, because ecosystems are really critical to achieving, to this nexus. Services from ecosystems, such as natural infrastructure, really underpin the three securities of water, food, and energy. Without healthy ecosystems in well-functioning watersheds, the infrastructure for built irrigation, such as hydropower or municipal water supplies, are not going to function sustainably. So we really need to look at our ecosystems. And in 2005, between 2001 and 2005, world experts did this Millennium Ecosystem Assessment. And one of the things that they found out is that ecosystems are doing very badly, and we really rely on the services that they provide, and especially some of the ecosystems that are most degraded are aquatic ecosystems. They're really being affected. 60% of them were affected, were in very poor condition. So I'm now borrowing some slides from some colleagues. We've been working with the International Union for Conservation of Nature and the International Water Association. They're undertaking this Nexus dialogue, and we're working with them quite a bit on bringing in the ecosystem dimension of the Nexus. So what do we mean by ecosystem services? And these are the benefits that people receive from nature. Some of these are, water purification, flow regulation, water storage. Those are, what we call regulating services. There are provisioning services like, food for crops and fish. Biofuels, for example, is also a provisioning service. Supporting services such as nutrient cycle and soil formation, and also cultural services, aesthetics and recreation, which are equally important for human well-being. And just zooming in a little bit again on the water and energy part of this nexus, these provisioning services, the crops that we produce, are key to produce bioenergy, for example. The regulating services, such as water flow regulation, are crucial for hydropower generation. And of course, supporting services such as soil formation, long-term peat and prehistoric fossil fuels are crucial for energy production from fossil fuels. So, this is really an area that needs to be taken into account. So, zooming back again at the broader nexus, the water, energy, food nexus, to guarantee the availability of water for people and for food and for energy, we really need to think beyond the traditional gray infrastructure. Nature is really part of the infrastructure that we have, and we need to really think of it as such. And putting this in the context, another important context here is rapid urbanization, which is really something to be taken into account very seriously, because the global population is becoming increasingly urban. Today, 1 in 2 people on the planet live in a city, so 50% of the population. And urban population is projected to increase by 2.9 billion to a total of 6.3 billion in 2050. And as you can see on this graph, a lot of this growth in urban population is happening in less developed countries. That's the darker blue. The lighter, the green is really cities that in developed countries that have been there. So the cities that are growing very rapidly, for the most, are in the developing world. Also, as I mentioned, today 1 in 2 people in the planet live in a city, and also every second the urban population grows by 2 people, which is really kind of mind-boggling when you think about it. So, water uses energy, energy uses water, agriculture uses both, and modern societies require all 3. And, we really need to look, especially in the context of rapid urbanization and of being able to provide the very necessary energy and food that people require. We really need to think of these issues in a much more integrated way. We have really been managing this in the silos, no? So there's the water sector, there's the energy sector, there's the agricultural sector, and we really have not yet achieved to manage them in a much more integral way. So we may be able to achieve great gains in terms of energy provision to the detriment of food production, for example, in the case of biofuels. And that was one of the reasons why this issue of the nexus came about, was, as I mentioned before, when we started to look into biofuels, but suddenly crops for energy production were competing with crops for food production. So, we run into these types of problems when we work on the sectors in parallel as opposed to integrating them. And so we know that we will need a lot of investments in water infrastructure, in the coming decades. It's estimated that we'll need to spend an estimate $1 trillion per year on water infrastructure by 2030, and global demand for food and energy are going to increase at a similar pace in the coming decades. So the need for integrated planning to meet these needs, as I was mentioning before, and to find lower cost solutions that can meet multiple needs rather than creating conflicts is what this nexus is trying to achieve. So going back to our ecosystems, so what is the role of natural infrastructure? You know, we're not going to be able to suddenly only use natural infrastructure. There's a real need for a gray infrastructure development. We will continue to need our pipes and that sort of thing. But, you know, natural infrastructure does provide a lot of the services that this built infrastructure provides. And, you know, you can see some of this here. You know, for example, wetlands. What we do with built infrastructure, for example, water filtration, you can do that with a natural infrastructure such as wetlands to remove pollutants, and the examples are many. So we don't need to replace them, to replace gray infrastructure. We need to better utilize ecosystems so that we can optimize the gray infrastructure that we utilize and that we require. And as we do that, we need to protect those services or compensate the people who are protecting those services for us. So, you know, a good example of this, and maybe I can go here, you know, one of the classical models in which this has been done is the payment for environmental services, and where, you know, downstream beneficiaries, for example, if you're a if you're a hydroelectric dam downstream, you don't want to have siltation too quickly, or if you need water for a reservoir for a city. If you protect your ecosystems upstream, your forests, you're going to guarantee that you have the amount and the quality of water that you need downstream for a much longer time. So how do we achieve this? How do we protect upstream? Well, one of the ways that we can do is for, you know, water facilities and others to pay those users upstream to better manage their lands. And a good example of that is in the Catskills in New York, where New York City really is relying quite a bit on what happens upstream and has done a huge effort, and it's really paid off very well. So why don't we have more examples? Why can't we continue to do this at the necessary scale around the world? And this really means can really mean some true benefits in terms of dollars. I mean, we really need to build a lot of infrastructure. Even in the developed world, we have aging infrastructure that needs redevelopment. And you know, if we could use some portion of this, not just for great infrastructure, but to protect our natural infrastructure, you know, this would be a great uptick for ecosystem, and they provide a lot of additional benefits. So this is an example from Portland, where the World Resources Institute, a colleague who's working on natural infrastructure, presented this very recently, where, you know, this is, you know, a most optimistic scenario of investments over 20 years. And you can see that you can have either at the very right, you know, your membrane filtration, you know, your purely gray infrastructure, or you can do a series of things like reforestation, riparian buffers, conservation easements, etc., to achieve the same thing that you would achieve at a lower cost. Of course, you can't always replace one with the other, but oftentimes you really can integrate the two. And what you achieve in turn is also a lot of additional benefits, such as carbon storage, you know, sustainable food production, recreation, better ecosystems, wetland and stream restoration, better habitat for wildlife. So you wouldn't have all those additional benefits if you only deal with your gray infrastructure. And before I forget, another good example is where I live in Washington, D.C. I received recently a letter from the DC Water, the public water utility, telling us about this Clean Rivers project. I mean, they need to do some serious improvements on their gray infrastructure, but one part of it, they're really trying to reduce the size of some of the pipes that they would need to put to deal especially with their combined sewer overflows, which is a huge issue in many cities here. And so they're looking at different opportunities to integrate natural infrastructure to be able to not only reduce the cost of this project, but also provide all those additional benefits of having green spaces in the city, etc. So, I think it's quite good that it's happening in my town right now too. So I won't go too much into this. These are some examples of UNEP activities. I've mentioned some of them. And some recent publications, including the Bioenergy and Water Nexus, and also Ecosystems for Water and Food Security. And don't forget, when you go home, to go to the website for World Water Day, and there's this really good new report on water and energy. So some of the takeaway messages, water supplies are limited and demand is increasing. So we really need to do a lot more to increase the efficiency in our use of water. We need to reduce pollution, and we have a lot of opportunities to protect and enhance ecosystems so that they in turn can provide the services that we need for our for development, but also for food production, energy production, etc. As I've mentioned many times, water, energy, and food security are really linked, and they really need to be managed in a much more coordinated way. And this is not yet happening to the extent that it should. Ecosystem services, as I mentioned, underpin this water, energy, and food security. So we really need to look at ecosystems as part of the infrastructure that is going to help us provide water for the people, as well as for the ecosystems, produce energy, and provide food for people as well. Saving energy is saving water, and saving water is saving energy, so keep that in mind every day. When you turn off your light, you're also saving some water. They're very connected. And very importantly, the bottom billion urgently need access to both water and sanitation services and electricity. And we need to help, the world needs to really strengthen our efforts to provide those. But we need to do it in a smarter way from the way that it's been done so far. So we really hope that with these Sustainable Development Goals, we can continue the great work that the Millennium Development Goals have done, some of which has not yet been fully achieved, and move forward for a better future where ecosystems are also protected for our long-term sustainability. So thank you very much. I think I went a little bit above time, but I hope you enjoyed. And of course, I once again want to give a shout out to the University of North Carolina students. Please look at their project, the 100 Gallons project. It was a great find as I was preparing for this presentation. Thank you.
At this point, I'd like to open the floor to some questions. If there's anyone that has a question that they'd like to address.
One of the slides.
Go ahead.
Oh, in one of the slides, there was a depiction of the efficient use of water in the Asian, Russia, Mongol. There was a section in there that was 100% versus about 80% for the United States. What are they doing that we're not?
Which one was this?
It was in the efficient use of water sources, right near the beginning.
Way back towards one of the first, I think, 10 slides.
Yeah, see right from Europe, Western, Eastern Europe, all the way across to Mongolia, they're a blue color, which is 100%
Right.
efficient, whereas over in the United States, we're a less efficient color. So what are they doing that we're not doing?
I think they're doing different types of systems, drip irrigation, many others, but I think the key issue is that there's so much water here. And this is the notion that we have, that, we have plenty. Why do we need to make all those extra costly efforts to use less of it if we have plenty. And I think in other parts of the world, I mean, it's not surprising that, you know, in parts of the world where there's less water, a lot more energy efficient practices are being implemented. So, you know, it's different things from, you know, irrigating with flooding is very water intense, whereas using drip irrigation, sprinklers, you know, it's less water intensive than through flooding, but of course you can have a lot of evaporation through that. So, you know, Israel, for example, you know, with so little water availability, they're experts in, you know, drip irrigation systems. But for many of the farmers in North America, this seems like too costly and not needed. Of course, now with what's been happening in Western U.S. and, you know, in California, farmers are really starting to look at this, and you know, they may need some you know, assistance from the government for the right things. So we maybe need to start subsidizing some of the right things and not the wrong things.
We have questions. Could you give us a report card on which countries are really doing a great job with water use?
Well, some of the countries that are doing very well is, for example, Israel is doing quite well. Also in South Africa, they've implemented a lot of very good you know, water efficiency techniques. Do you mean just for agriculture or in general?
In general.
Oh, in general, I mean, also, I mean, Europe has done great in terms of also municipal water use, and, you know, there's systems where you can, where you reuse your gray water, you know, from the showers to use it to flush toilets. I mean, it's really kind of amazing how much water we draw. We purify it to the level of drinking, and then we flush it down the toilet. I mean, that is the most inefficient way. And of course, purifying water requires a lot of energy as well. So, I mean, we are both wasting water and energy at the same time. And so, you know, I've been very glad to see that the bed and breakfast where I'm staying here, they're implementing low flush toilets. I hear that this part of the U.S. is doing quite a few things like that. But yeah, and I think many parts of Europe, some parts of Latin America, I mean, many parts of Latin America have a lot of water. So usually the key is wherever there's a perception, real or perceived abundance of water, people don't implement so much of this. And, you know, it's pretty crazy how in Mexico City, which is in a really dry region, where they have drawn so much of their aquifers that some of their pipes are now like 20 feet above ground, pipes that used to be underwater. And part of the city, I mean, you can see the cathedral is, you know, has sunk, and some buildings are sinking. We still have a lot of the traditional, you know, toilets that use a lot of water. I mean, of course, some programs have been implemented, but not to the extent. And what they do is they bring water from further and further away, which of course takes water from other regions and also is very costly to bring to a very high. So Mexico City is in a pretty high altitude. So you're pumping all this water upstream. So that's perhaps not a good example, although many things are starting to be implemented to improve this water efficiency.
In the back there, and then
You mentioned briefly desalinization. We're just more what any improvement in that is happening, or what the disadvantages of it are, where it's going on.
Well, it's happening quite a bit in Saudi Arabia, and I know I had a pretty good graphic, but basically, actually it's here in the Nexus, a good example of you know, salinization, desalinization. The problem is that it's extremely water intense. Here you probably cannot see it, but on the left it says Saudi Arabia's desalination plant used 1.5 million barrels of oil every day in 2010, and that's 1/6 of their output, their oil output. And this is to quench the to quench the thirst of inland cities. So, you know, when you have places like Saudi Arabia where, you know, they have enough oil, at least for now, they can, you know, they can take the luxury of using a lot of their energy to desalinize water to be able to consume it. But, you know, for many parts of the world, this is not the case. And, you know, and once again, this is a very energy intensive way of getting water for people. So we're also, in addition, causing further problems in terms of, more CO2 in the atmosphere and climate change, etc. So, it probably, unless the technology significantly improves, and there's actually quite a lot happening in terms of research for much less energy-intensive water desalination, using some, I don't know the specifics, but using certain types of membranes where, water will go, as it usually flows, from where it's more concentrated with salts to where it's less, using certain types of membranes with barriers. I don't know the specifics, but ways that use less energy. But none of this have been able to be implemented at a scale large enough to be able to say, hey, we are we have so much seawater, why are we worrying about it? We can.
Doesn't Israel have used significant amount, or they're not still not with Israel?
I know they do, but I don't know to what extent. Sorry. Yeah. In the case of Israel, I know in the case of Saudi Arabia, they do. I think it's the part of the world that does the most desalination.
And so you had a question?
Yes, I know that one of the concerns about reducing CO2 emissions is the cost to industry, additional cost, and is there a comparable sort of issue with water so that somebody would have to pay more, thus it becomes a political controversy if we make adjustments you're talking about?
Well, it's a big issue, and I think one of the good examples, and I hope this kind of answers your question, is the case of biofuels. So part of the reason we started to look more into biofuels is to reduce, to not have to use so much oil and gas to produce electricity. However, we only have so much land and so much water, and suddenly, agriculture was competing for providing food for people and providing energy, and that's why in around 2007 or so the prices of food really spiked up, and it's one of the reasons why this discussion on the nexus really started, because you started to have a lot of political unrest in many parts of the world where suddenly people were not being able to eat some of their traditional staples because they were too expensive, because they were being sold at a higher price for energy production. So, there's a lot of trade-offs, and it's difficult politically.
Okay, along that line, will there be a political opposition to the measures you're talking about because of the question whether private interests pay or government pays directly? Is there sort of a consensus that if we have the money in the governments, we'll spend it this way, or will there be an attempt to put some of that on the private sector, some of the costs on the private sector?
I think more and more, governments are looking to the private sector, not just, really to try to help with some of these solutions, because they are big users of all of this, of food production, agricultural outputs, of energy outputs, of water. So, this is, and as I mentioned before, to a certain extent, they are really thinking about this. Now, in terms of, what different governments might do to, get industry to work in the way that we would like to, and make the changes that we would like, that varies very much between countries. There are countries that are much more willing to regulate the way industries work, and there are countries where we really sort of leave it to the market. And I think here in the U.S., especially now, we're very anti-regulation. So we hope that industries are seeing, and they, to a great extent, they are seeing the importance of managing the water and energy use more efficiently, because it's in their economic interest as well. But other countries are able, in Europe, for example, are able to get industry to do things, move industry in a certain way quicker through, taking away subsidies, implementing some, benchmarks. You have to, reduce your water consumption by a certain amount, and quickly, oftentimes, industry is able to deal with the changes. I mean, to give an example from Germany, maybe not so water related, but in the case of their chemicals industry, they became, because the German government imposed some limits, like you should not, in your chemicals production, you should not utilize more than a certain amount of energy and water. They were able to improve their technology. So when the world economic crisis occurred, starting in around 2008, in the end, German industries, chemical industries, ended up doing quite well because they had already done some of the technological changes to be able to recycle a lot of their water, a lot of their energy within their system so that they wouldn't lose so much. So they're less dependent on, changes in oil prices, etc. So, if you're those industries who can look a little bit more than short-term profits are often going to do it themselves. But of course, governments have a lot of power in terms of getting them to do so quicker.
One quick question on fracking. I know we're running out of time, and she will be available afterwards for some questions. I was just asked, no, I think I can project, about fracking. Fracking uses a tremendous amount of water. Not only that, it tends to contaminate the groundwater supply. So not only are we using a tremendous amount of our surface water or available water to society, but we're contaminating future water supply. So we're not being very forward-looking. Is there a way that you think that we could address this so that we can think of the holistic view of how water is being used, not only at the moment, but also how we're affecting the future generations and their water supply?
Well, this is a tough question, and especially it's a very political question at the time. And I must say I don't really know enough about fracking, but I do know that first of all, it's pretty water intense. I mean, you need to put in a lot of water to break the shale to get the gas that you need. So in terms of water use, it's pretty water intensive, and of course the big concern is contamination of water. Which we've been seeing around the U.S., people lighting their matches on their tap water, which is pretty scary. But yeah, I don't really know so much more about it, other than it's pretty water intensive. Why aren't we doing much more in terms of photovoltaics, which are much less water intensive? Why can't we do much more with wind power, which is uses minimal water just to clean the turbines every now and then? So we can look for better alternatives.
And then in a final note, I would like to just mention, years ago up in DC, I heard a benefit from hearing a man speak who was a Nobel laureate in economics, an older man in his 70s. And he spoke very elegantly. He said, I've been around for a long time. I remember when the Clean Water Act was implemented, and the industry stood up and said, we can't afford it. It will destroy the economy, we'll lose jobs, we'll lose competitiveness. Our economy will go down, we'll go into recession. It is an untenable prospect for us to spend that kind of money and that kind of resources cleaning up our water. He said, look at the economic record. Our economy grew. We created new industries. We created jobs. We cleaned up our environment. We improved our quality of life. We exported our technology. We became world leaders. So we can make changes that don't just have economic cost. It can be a win-win scenario.
And I really want to echo that. And one of the things that UNEP has been working on quite a lot in the last 5 or 6 years is on the green economy. And there's a long set of reports looking at how we can green our economy. And we don't need it. I mean, there's always going to be some trade-offs, but it doesn't. You don't always need to improve your technologies to be more environmentally friendly. It's not always costly. It's oftentimes actually cheaper than in the long term. And the problem, one of the things that industry needs to look at is at longer term profits instead of shorter terms, because that's when then if you know that you're going to need this scarce resource for a longer time, you're more likely to be willing to invest to utilize it more wisely.
Great. Thank you, Carla. Let's get Carla. Tell a friend about the series. Come back on April 5th. That's, I believe, 2 weeks from today. Gil Rogers from the Southern Environmental Law Center will be talking more specifically. Carla's been great giving us the context, giving us models to think about, particularly this nexus, energy, water, food model. But now we're going to get into specifics. So we'll talk about Atlanta. If you've never been to Atlanta, there it is.
Enough said.
Enough said. However, there are some interesting things about Atlanta. They experimented with privatizing their water. At one point, they said, we're just going to give it to a private company. Come back, find out how that worked out. And before Gil Rogers is done, I said, Gil, are you a good public speaker? He said, well, I'm a stand-up comedian. So get him to tell a joke before the event ends. 2 weeks from today, and thank you for coming out.